9.2, solving quadratic equations by graphing. Okay, so when we're solving a quadratic equation by graphing, a quadratic equation might look something like this, where a, b, and c are numbers. Okay, it could be equal to 0 or something else, but first you'd want to set it equal to 0, and you want the x squared term first, then the x term, and then the constant. Okay, so you'd want to put it in standard form if it isn't already. Okay, so when you look down to these two examples at the bottom of the page, first thing I'm going to do is put them in that format. So they're in standard form. Okay, then what we're going to do is graph the related equation. So then we're going to, instead of a 0, we'll put a y in. Okay, and then if we find the x-intercepts are going to be the solution, because those would be the x-coordinates that would give you a y that equals 0. That's why we're plugging in the y where the 0 was in graphing. Okay? All right. So with a quadratic equation, you could have 2, 1, or 0 solutions, and that all depends on how many x-intercepts. So a lot of parabolas are going to have 2 x-intercepts, so they'd have 2 solutions. But, you know, if the vertex is right on the x-axis, it'll just have 1 x-intercept and 1 solution. And if it never crosses the x-axis, then it won't have a solution at all. Okay, so those are all possibilities. Okay, so let's get down to an example here. So first thing I want to do is take this equation and put it in standard form. So that means I want to set it equal to 0. I'm going to add 10 to both sides here. So then I'll have x squared plus 7x plus 10 equals 0. Okay? Now, next thing I want to do is graph the related function. So what I'm going to do is put in a y where the 0 is. And I flipped the whole equation around, but you could leave the y on the right side if you want to. It doesn't matter. Okay? And now we've got to graph this. So when we're graphing an equation in standard form like this, we have a couple of different options. So one way you could do this is to find the x-intercepts by factoring this. And then graph it from there. But you could also use the axis of symmetry formula to find the vertex and do it that way. Okay, so I'll do these two problems in different ways just to show you. But this one, I think I'm going to do this one by graphing, by factoring. So what I'm going to do, I just put a 0 in, but eventually I just put the y in, but I'm going to put the 0 back in for the y. But first I'm going to graph this. So I know it's going to look like this. I keep saying graph, I mean factor. I'm going to factor this. I know it's going to look like that. Okay. So let's set up a diamond problem here. I'm going to put the 7 on top and the 10 on bottom. Okay. And then I'm looking for two numbers that add to 7. The same two numbers multiply to 10. So 1 and 10 doesn't work. That won't add to, but I can use a 2 and a 5, right? 2 times 5 is 10, and 2 plus 5 is 7. And that tells me what goes in the back of my parentheses there. Okay? And now when I'm looking for the x-intercepts, I'm just going to put the 0 back in for y. Because when we find x-intercepts, you plug in 0 for y. And now I can use the 0 product property since I have this factored. So either x plus 2 equals 0, which means x would equal negative 2, or x plus 5 equals 0, which would mean that x would equal negative 5. Okay? So then I'm going to plot both those x-intercepts. I've got negative 5 and negative 2. And we don't actually have to graph the rest of the parabola here because we already have the x-intercepts, which is going to be the solution. Let's go ahead and graph the rest of this. So if those are the x-intercepts, I know the axis of symmetry is halfway between those. Okay, and I also know that this opens up, this parabola, since the x squared is positive. So I know the vertex is going to be somewhere down here. Okay, and what I can do is use the fact that I can go back to this and I can see, well, what happens? This would be negative 3.5 for the x, right? So I can go back here and say y equals negative 3.5 squared plus 7 times negative 3.5 plus 10. There's a little negative symbol there. Okay, so just use my calculator to quickly figure that out. Negative 3.5 times negative 3.5 is 12.25. And then 7 times negative 3.5 is negative 24.5. Okay, and then I got the plus 10. So now I'll do the subtraction and the addition. I'll do it all at once. And I've got negative 2.25. Okay, so I plugged in, I was looking for the vertex here. I knew that the x coordinate was from this axis of symmetry. It had to be on the axis of symmetry. So the x was negative 3.5. And then I went to the original equation here that I was graphing, and I plugged in negative 3.5 for x, and y came out to negative 2.25. Okay, so then negative 2 1/4, something like that. There's my vertex. But yeah, it's all a little bit more work than I needed, because ultimately this says to solve, and that means I'm looking for the x values of this equation, and I already knew that those were going to be the x-intercepts. So that means x equals negative 5 and negative 2. So this one had 2 solutions. So I really could have stopped after I factored and solved that equation. Okay, but there it is by graphing. Okay. All right, let's look at another. I'm going to first add 25 to both sides here. So now I've got x squared plus 10x plus 25 equals 0. Okay. Then I'm going to graph the related equation again. So I'm going to put a y in instead of a 0. Okay, I'm going to graph this parabola. This is the related equation to that one. Okay, so I'm going to do this one. I could factor again to find those x-intercepts, but I think I'll find the axis of symmetry first. Okay, so remember your axis of symmetry. There's a formula for it, and it's x equals negative b over 2a. So if you have your function in standard form like this, the b would be 10 and the a would be 1. It's the coefficients, right? 1, 10, and 25 would be a, b, and c. So I've got x equals negative 10 over 2 times 1. The a was 1, right? Now I'm just going to simplify that. So that's going to be negative 10 over 2, which would be negative 5. So that means the axis of symmetry is x equals negative 5. So I'm just going to put a little dashed line, and I know that's the middle of my parabola. Okay. So that means I know that the vertex is going to be somewhere on that line, and since the equation of the axis is x equals negative 5, that means I know the x coordinate has to be negative 5, because any point on that line is going to have an x coordinate of negative 5. Okay, so then I just need to find the y that goes with this. So I'm going back to the equation with the y, and so this part's just the same as the previous problem. I'm plugging in the y to find the x that goes, the x to find the y that goes with it. So negative 5 squared is positive 25. 10 times negative 5 is negative 50. And then I got the plus 25. So let's see, I get here negative 25 plus 25 when I add those first two pieces together, and hey, that adds to 0. So that means my vertex is negative 5, 0. Okay? Now normally my next step would be to try to find the x-intercepts, but I just found the x-intercept, right? It just so happens that the vertex is the x-intercept here. Okay? So if you could find the y-intercept, but it would be way off the top of the screen here. But it's going to look something like, it's going to open upwards because the x squared is positive. It's going to look something like that. It's only going to have one x-intercept, so that would be at negative 5, and that's my solution. It's honestly kind of a strange way to solve equations like this, by graphing the related parabola and then finding the x-intercepts, because you could just solve these without graphing at all. But that's what's in the book, and so that's what I'm showing you how to do. All right, so here is another to try. So first I want to get it in standard form, so I'm going to move the 4x to the left side of the equation here. Okay, and then so I've got x squared, and then I'm going to put the negative 4x in front of the 6 because I want the x term to come next, plus 6, and now it's equal to 0. Okay, and now I'll graph the related parabola, so I'm going to put y back in for 0, and yeah, like you could leave the y on the right side, doesn't matter. Okay, and now you can take your pick. You can try to factor it, or you could find the axis of symmetry first and start graphing from there. It's really up to you. I think I'm going to factor on this one. I'm going to try factoring. So I'm pulling a negative 4 on top from here, from the b, and the c is 6. That goes down there. Okay. All right, looking for two numbers that add to negative 4 and multiply to 6. So let's think about different ways to multiply to get 6. Well, those don't work. And let's see, these don't work either. None of those add to negative 4. So we've got to try something else. So this doesn't factor. So that might mean that our x-intercepts are not integers. They might be fractions or decimals. Okay. All right. So now let's try the axis of symmetry formula then. X equals negative b over 2a. So my b here is negative 4, and my a is 1. So I've got positive 4 over 2. So x equals 2 is my axis of symmetry, so that means this is the middle of my parabola. Okay, and I know this is going to open upwards, the parabola, because the x squared is positive. Okay, so let's find the vertex then. I know the x-coordinate has to be 2 if it's on that line. Okay, and then I'll go back to the equation. So this is to find the vertex here. And I'm going to plug in 2 for x in both slots. Okay, and this gives me 4 minus 8 plus 6. So let's see, 4 minus 8 is negative 4, and negative 4 plus 6 would be 2. So 2 is the vertex. Okay, so 2. Now I know this is opening upwards. I'm not going to really worry about the width too much, but remember I'm looking for the x-intercepts. And hey, this doesn't cross the x-axis. So that means there's no solution. Sometimes that will happen. Okay? Because it just is never going to cross the x-axis. So no x-intercepts, no solution. Okay? All right, let's look at the graph of a cubic function. So I've got a function that's graphed already here, okay, and it's here is the equation, and notice this is already factored, okay. It says find the zeros of the function. Well, the zeros are just going to be the x-intercepts, okay. So there's two ways you can do this. Since we have a graph provided, you can just look where the x-intercepts are. They're going to be at negative 1, negative 1, negative 5, negative 1, and positive 3. But you could also take the equation and just plug in 0 for y, or for f of x here. And since this is already factored, it's pretty easy to solve for x. We can just use the zero product property. One of these products has to equal, these factors has to equal 0 because the product is 0. So, you know, one of these things has to equal 0 because we're multiplying together to get 0. So let's just check this. If I solve that one, x equals 3. Well, hey, that is one of them on the graph there, right? That's that one. And then if x plus 1 equals 0, then I got x equals negative 1. And hey, that's that one right there, right? And here, let me go over here. And if x plus 5 equals 0, then x equals negative 5. And that's that solution, okay? So that's the idea, is that the x-intercepts are going to correlate with the solutions of the equation. And the solutions are the zeros of the function. The solution, it would be a solution if you already had a 0 in for f of x, and it's a 0 when you have f of x or y in the equation. Okay. All right, that's the end of the section, and I'll see you next time.